This is very interesting and very important. Questions like this come very often in different aptitude tests and licensing exams. Following circuit is proposed for measuring and displaying temperature. Required temperature range for the overall circuit is negative 100.1 degrees centigrade to positive 100.1 degrees centigrade. So there's a range given over here, and the required resolution, actually this should be resolution, not solution. The required resolution of 0.1 degree centigrade plus minus 0.1 degree centigrade. So that's significantly low. If you look at the circuit right here, again, you know, it's an op-amp right here. The positive terminal here is connected to the temperature sensor. That's where the temperature sensor reading this goes into op-amp. And you have a feedback resistor and then in some resistor in some configuration, right? The output of the op-amp, that's what's important here. The output of the op-amp, whatever that output is then fed into an analog to digital converter. And this analog to digital converter could be, you know, 6-bit, 8, 10, 12, or 14 bits. And the output then, of course, is fed into LCD display, the digit display, basically. What we need to do here, we have to find out the minimum number of bits required for ADC, the minimum number of bits for ADC to achieve the specified temperature resolution. Okay, whatever that comes out, the ADC should be able to respond to that output, and therefore we need to find out the minimum number of bits required, whether it's 6, 8, 10, 12. So how do we get started? Well, here is again a very famous equation. The resolution depends upon, it's basically a ratio of the full scale range to divided by 2 to the power n, correct? Where n is going to be the number of bits. And as you know, that's what we are looking at. We are looking to find out this n, correct? Full scale resolution is basically just simply going to be the addition of the full scale range. The full scale range, so it's basically the temperature in the positive range minus the temperature in the negative range. C plus is 100.1 degrees centigrade. C minus is negative 100.1 degrees centigrade. Negative and this negative will become positive here, and therefore there is a positive sign. So if you add the two, you get 200.2 degrees centigrade, and that is your full scale range, correct? Now, what I did, I basically took this over here and bring the resolution, rearrange this equation, and then put it in this format, where number of steps or resolution, number of steps or to the power n, whatever you want to say, equals to full scale range divided by resolution. Range is 200.2 degrees centigrade. Resolution is given 0.1 degree centigrade. If you do the math here, you will get 2002 steps. So we basically need 2002 steps to go up and cover this range, right? At a resolution of 0.1 degree centigrade. Now again, if you do a little bit of math, if you go to the power n, where n is equals to 10, that gives you 1024 steps. We are looking for a number of bits that would give us a range which will include this number right here. It needs to be equivalent to this or greater, correct? Not less than that. So 1024 is less than 2002. But if I increase the number of bits to 11, say, now I got the maximum range value 2048, and this value is within the range. Therefore, the number of bits, we basically require an 11-bit converter is required. And that is your answer. Okay. Now, maybe, you know, you could also say because 11 is not an option over here, we can also go with 12. As long as whatever the number of bit has covered this value 2002, we should be fine. I hope you like this video.